A resting neuron has an electrical difference across the cell membrane known as the resting membrane potential. The inside of the cell is negative compared to the outside of the cell, and this can be measured in volts. A resting neuron has a resting membrane potential of about minus 70 millivolts. This can vary, but this is a typical value. If a neuron crosses the threshold voltage, if the voltage depolarizes to the point of minus 55 millivolts, this is the threshold voltage at which point the voltage-regulated sodium gates open. Once again, these are voltage-regulated ion gates. They are closed at some voltages and open at others. When the neuron crosses the threshold voltage, these gates open. Sodium now has the opportunity to rush from its area of high concentration to an area of lower concentration. So sodium rushes into the cell, and as positive ions rush into the cell, the membrane potential increases to 30 millivolts. At this time, the sodium gates close, and the potassium gates then open. The potassium gates are also voltage regulated and also open in response to crossing the threshold voltage, but their opening is a bit delayed compared to that of the sodium gates. So as the potassium gates open, the potassium ions can now go from an area of high concentration to low. They can go from the interior of the cell outside the cell. At about minus 70 millivolts, the potassium gates close. Now, the membrane potential has become negative because of all of the positive potassium ions which leave the cell. Once this has concluded, the area is once again at rest, although the sodium-potassium ion exchange pump will now have to work to redistribute the ions, pumping the sodium which had entered the cell back out of the cell, and pumping the potassium which had left the cell back into the cell. These are the events which occur at a section of cell membrane during an action potential.